Happy morning, students. Welcome to your geography class. The topic today is elements of a map. Yes, we have already covered three elements of a map. They were map title, map directions, legend, or a key. Clear? So today we are going to cover other elements of a map. Let's start. So yes, students, we have covered three elements of a map. That was title, legends or keys, and direction. Remember what is a title? The title tells you the purpose of the map. Okay, means what is inside the map. Then we did legends. Legends show what symbols on the map mean. The legend is the key to unlock the secrets of a map. Objects or colors in the legend represent something on a map. Then we did directions. Direction is shown on a map by using a compass. The compass shows the directions of the map so that map readers can relate those directions to the real world. Sometimes a compass will just show north. If you know which way north is, you can figure out east, west, and south. So we did cardinal directions and intermediate directions. Cardinal directions are north, south, west, and east. The intermediate directions are north, east, southeast, northwest, and southwest. So the topics for today are scale, conventional signs and symbols, colors, grid system, and heat zones of the earth. So let's do them one by one. The first is scale. The scale of a map is the ratio of the distance on the map to the corresponding distance on the ground. Let's try to understand. To read a map, you need to refer to a set of instructions in order to understand distances in real life. A map scale is the ratio of the distance on a map to the actual distance on the ground. Map scales can usually be found on the outer edge of a map, usually near the map's key. Whether the scale is drawn out or written, you can easily calculate the distances if you know the ratio. I tell you how. In simple words, we can say a scale is the ratio of the distance between two places on a map to the actual distance between the same two places on the ground. So there are three types of map scales: graphic scale, verbal scale, representative fraction. Let's do them one by one. So the first is verbal map scales. Also called word scale, uses words to give the ratio of the map scale length to the distance on Earth's surface. Let's try to understand. This scale is stated in words. The units are usually mentioned in this type of scale. For example, 1 centimeter is equal to 2 kilometers in this map. Another scale is 1 centimeter is equal to 1 kilometer. Here, scale 2 centimeter is equal to 1 kilometer. So you can see three different types of statement or verbal scales are given depending upon the areas. Okay, so here it means the 1 centimeter on the map is equal to 2 kilometer on the ground. Okay, so it is given in the form of a statement. So here also 1 centimeter on the map is equal to 1 kilometer on the ground. Here 2 centimeter on the map is equal to 1 kilometer on the ground. It means smaller unit is for the map, okay, and the larger unit is for the land or the ground. Next we have linear scale. It is also called as bar scale, scale bar, graphic scale, or graphical scale. Now what is it? This scale consists of a straight line. Okay, you can look here. Straight line which is divided into lengths that represent given distances on the Earth's surface. It is usually drawn near the lower portion of the map. So it is a special kind of ruler on the map that is divided into equal units of distance. Let's have a look here. This is one map where you can see below the scale is given. Okay, can you see the linear scale below? Yes. The third type of scale is representative fraction. In short form, we call it as RF. So a representative fraction is the ratio of distance on the map to the distance on the ground. Representative fractions are expressed in the form of 1 followed by a colon and then a number. Look here. Yes, where the 1 is the numerator in the fraction, the colon represents the division operation, and the other number is the denominator. Clear? Thus, the scale of 1:24,000 can be expressed mathematically as 1/24,000. In fact, on some maps you will see the RF represented using a division sign. Okay, now let's understand. This is a fraction in which numerator expresses the distance on the map and the denominator represents the actual distance on the ground. It must be noted that the numerator is always 1 and both the numerator and denominator are expressed in the same unit. Okay, for example, here 1 is the distance on the map and 24,000, whatever unit we use here, that will be the distance on the ground. So how we write it? 1:24,000 or 1/24,000. So it's in the form of a fraction. Clear? So it means 1 centimeter on the map represents 24,000, if it is centimeter, 24,000 centimeters on the ground. Clear? So it means if we take unit as centimeter, okay, so 1 centimeter on the map represents 24,000 centimeters on the ground. So the unit on both sides, that is numerator and denominator side, should be same. Okay, what we did in the statement scale, both sides units are different. Okay, for the map we are using the small unit and for the ground or land we are using a larger unit. But here we are taking in the form of a fraction. So 1 and 24,000, both these numbers should have the same unit. So it means 1 centimeter, okay, on the map represent 24,000 centimeter on the ground. Clear? So we have covered 3 different types of scales. They were verbal scale, linear scale, and representative fraction. Next topic is conventional signs and symbols. Yes, what are conventional signs and symbols? They represent various features shown on a map and they're not drawn to scale. Look here. How do we understand the map with the help of symbols? Maps show features in a plan view as birds see it from above. It is impossible to label every single feature in words on a map. Therefore, we use map symbols. Every map is accompanied by a legend or key. The key is essential since it contains what each symbol on a map stands for. Such symbols may be drawings, letters, lines, as you can see in front of you. It can be shortened words or colored areas. Most map symbols are conventional signs as they are understood by everyone around the world. For example, a lighthouse, a church. So these are symbols which are used in all the maps across the different countries, okay, in whole of the world. So let's read all these symbols. You can see this triangle. So it is a peak, a mountain peak. Then the symbol of aeroplane for the airport. Then this is for capital. Then town and city, black dot. Roads, 2 black parallel lines. Railways, path. Okay. Then international boundary, a thick black line. State boundary is a little thinner. Then district boundary, a dotted line. Then industry. Then mountain pass, river, hospital, okay, and mountains. So these are the conventional signs and symbols which are always universal and they're universally accepted, okay, by all. Now let's move to our next topic, that is colors used in maps. Many colors used on maps have a relationship to an object or feature on the ground. For example, blue is almost always the color chosen for water. So, cartographers use colors on maps to represent certain features. Color use is always consistent on a single map and often consistent across different types of maps made by different cartographers and publishers. Okay, here we can see various colors being used for a specific feature. For example, green color for forest, yellow color for the beach, shallow water if you're showing you're using a light blue color. If you're showing deep water, it's a dark blue color. Then rock with this violet color and the grass with light green. So colors in maps are really important. So there are few colors, okay, which represent different natural features, geographical features of our earth, like blue color for water bodies, blue dot for well, then orange color for plateau, green color for vegetation, red dot for a city, yellow for the desert, contour lines. Remember what are contour lines? Yes, used in the topographic maps. Contour lines and elevation numbers, we usually use the color brown. If there is no vegetation or sparse vegetation, sparse means very less vegetation, we use the color white. Even for frosted land, okay, that is a frozen area where ice has formed, so we use the white color. Clear? So colors play a significant role in maps. They make maps attractive to look at and easy to understand and interpret. On physical maps, the different colors are conventionally used in this way. Blue color for water bodies such as oceans, seas, bays, gulfs, lakes, rivers, and streams. Green color for lowlands, plains, coastal, and those built by the rivers. Then brown color for hills, mountains, plateaus. Yellow for hot deserts and white for cold desert, snow-covered regions, as I just told you. Clear? Now, let's move to our next topic, that is a grid system. What is geographic grid? It is a network of the latitudes and longitudes. Okay? Geographic grid. The network of the latitudes and the longitudes is known as a geographical or geographic grid. I hope you know what are latitudes and longitudes. Yes? So, a network of horizontal and vertical lines or latitudes and longitudes drawn on a map or a globe. Here you can see these lines on the map. I'll show you on the globe also. Is called the grid system. Now, what is the advantage of a grid? Yes, it helps us to locate a particular place accurately. Clear? So you can see here, these are the horizontal lines, okay? That is 0-degree equator dividing the earth into two equal parts. Then we have 20-degree north, 20-degree south. So, you know, equator divides the earth into northern hemisphere and southern hemisphere. Okay. So, here this is 0-degree and then it comes to be 20-degree north, 40-degree north and 60-degree north. Similarly, we go down towards the south, 20-degree south, 40-degree south and 60-degree south. Clear? Then we have longitudes, these vertical lines, okay, which is the 0-degree longitude. Here, this is 0-degree, which is known as the prime meridian. Clear? So, prime meridian divides the earth into western and eastern hemisphere. Clear? So, you can see here, it is 20-degree west and here you have 20-degree east. Similarly, on the other side of prime meridian, you have 40° west, and on the eastern side you have again 40° east. Longitudes and latitudes, okay, they are running all across the earth, okay. They are the imaginary lines drawn to locate the particular place. Similarly, so you can see this grid in the globe also, okay. The globe with grid formed by parallels of latitude and meridians of longitude. Here also you can see this equator 0°, okay, dividing the earth into two equal parts. And then when you go towards north, you have 10°, 20°, that is north, 10° north, 20° north, 30°, and goes on till 90° north, that is the North Pole. Similarly, when you go towards south, 10° south, 20° south, 30°, and when you reach 90°, okay, it becomes 90° south. So these are all latitudes. Let's talk about longitudes. Now this is the prime meridian, that is 0° longitude. Clear? When we go towards the west, we have 10° west, and here we have 10° east. Similarly, 20° west, 20° east. Okay, 30° west, 30° east. So this grid, okay, it helps us to locate a position of a particular place. Clear? For example, you look at this point. It is located at 40° north and 30° west. Means this particular area, it is located in the northern hemisphere and in the western hemisphere. Okay, and we know the latitude and longitude also, okay, which is telling the exact position of this place. Clear? So yes, students, I hope you have understood whatever topics we have covered. Okay, we have talked about scale, different types of scale, then conventional signs and symbols, then colors used in the map, and then we were talking about geographic grid. Okay, so we will continue with this topic in the next video. So thank you everyone. That's all for today. Have a nice day.